Assalamu alaikum everyone, hope you're all fine. Welcome back to my channel. Today in this video I'll be doing the computer science 9618 paper 2 A level, and the topic is ADT queue. Abstract data type queue uh, is a collection of data type that operates on first in first out principle, that is the FIFO principle. So this FIFO principle means that the items can be added to the queue from the rear and removed from the front. All right. So this is the ADT queue, and we can take an example of a queue of the people standing, and you can see that any person added in this queue will come the from the rear. This is the rear side, and so entry is from the rear, and the exit, the person who will enter in this queue who came first will leave first. All right, so this is from where, this is the front, and the exit is from this side. All right, so queue is a type of a data structure, and in which the data is collected and is operated in with the FIFO principle, and items can be added to the queue from the rear and removed from the front. All right, so so in this queue we can also assume the queue like the balls in a beaker. So we can assume that the balls, it can be like a small funnel. This is the ball 2, ball 3, ball 4. So the exit and entry, this is the front and this is the rear. So the exit is from the front and entry is from the rear. So this is the basic thing that you must consider for the queue. All right, now moving next, the main important aspect with which we can differentiate it with the stack is that the entry and removal is done from different end. All right, while in the stack this was done from the same end. In the stack there was only one side from where the item is added or the item is deleted, but in the queue the items can be added into the queue from they are added into the queue from one end, and that is the rear, and they are removed from the other end, and that is the front. All right, so based on this we can say that the item that comes first will leave first. So in the queue, the item that will come first will have the shortest stay. All right, but in the stack the item that comes first has the longest stay. This is how the queue is different from the stack. Okay, now the next thing is that the variables or the pointers for the queue. So now we have the front pointer and we have the rear pointer. All right, and then there are two more variables that we will need in this queue, is the queue length, and one is queue full. All right, so these are the variables that we will require, we will use in the queues. One more thing, in the queue, adding the value in the queue is called, adding is, which is done from the rear, is called Enqueue, and the exit, which is removal, is called Dequeue. All right. So keep these two terms in your mind. So entry, which is done from the rear, is called Enqueue, and the removal, which is done from the front, is called Dequeue. All right. Okay. Now moving forward. So now if this is the, let's say this is the queue. Now it has element 1, 2, 3, 4, 5, 6. For example, there are elements 1, 2, 3, 4, 5, 6. Now in the queue, when the values, for example, there are certain values. Let's assume there are some values in this queue: 5, 9, 4, 6, 7. So now where will be the front pointer? Front pointer will be here, and the rear pointer is here. All right. This is the status of the queue, and this is the. And now what is the length? The queue length right now. Queue length is now the number of the elements between front and rear pointer. 1, 2, 3, 4, 5. So basically, this is the queue length. So this is 5. And what is the queue full? Queue full is the maximum capacity of the queue. So queue full right now for this case is 6. All right. So these are the things that you will consider before moving toward the next important concepts. That for a queue, we have the location, we have the positions of the queue front pointer, the position of the rear pointer. So front pointer is telling the index from where the value can be removed, and rear pointer is the place from where the value can be added. Okay, and the queue length is counting the total number of the elements that comprise a queue, and the queue full is the. So what is the queue length? It is important to mention the queue length because queue length is the total number of items in a queue. All right, and queue full is the maximum capacity of queue to hold data. All right. So these are the things that you must remember about the queues. All right. So now the in the queue, the one very important thing, and that is the Enqueue, which is adding an item. Adding an item into the queue is called Enqueue. So when an item is, whenever an item, when an item is added, it will be added from the rear, number one, and only the rear pointer is incremented when an item is enqueued. All right. So enqueue will only increment the rear pointer. So the rear pointer will only be added. So only the rear pointer will be incremented whenever the value is added. All right, so let's see this. So let's see this with the help of the example. So we have a queue, and the arrays, the values index 3, 5, 6. So for example, this is where the front pointer is pointing, and it has 10, 15, 18. So here is the rear pointer. And now we want to add a value into the queue. So in order to add or to enqueue, what we need to do, the rear pointer is going to be incremented. So the rear pointer incremented means this rear pointer we will increment first, we'll move it to the next index, and then the new value will be added here. So the new value will be added here. Okay, so this is how. So with three things, when we are enqueue, when we are adding the value, what we are doing, the number one, the rear pointer is incremented. Number two, the value is enqueued. Number three, the queue length is incremented as well. So these things we need to do when we add a value. All right, so whenever the value is added, so we need to consider these things, that the rear pointer is incremented first, the value is enqueued, and the queue length is also incremented. Okay, and what happens when we, this is the enqueue, and what is the dequeue? The next is the deleting. Delete an item which is dequeue. Deleting an item which is dequeue. And when we delete an item, the way when the item is deleted, first of all, the item is deleted always from the front. This is the first rule. And second is that only the front pointer is incremented to delete or dequeue an item. All right, so for this, one thing that I can write here in the enqueue is that enqueue is the rear pointer plus 1. All right, so only the front pointer is incremented. So what we will write, front pointer is front pointer plus 1. All right, so you have seen that in the queues, there is always increment. So when the value is added, the rear pointer is incremented, and when the value is removed, the front pointer is incremented. And you must remember that for the stack, when the value was added, the top pointer was incremented, and when the value was deleted, means the pop was done, the front pointer, the top pointer was decremented. All right, so in the stack, we did the increment or decrement for push and pop, but in the queue, we are always incrementing, but the different variables. To enqueue, we are incrementing the rear pointer, and to Dequeue, we are incrementing the front pointer. But as you have seen, and now I'll show this before we write the key points. I'll show this in the with the diagram as well. Now this is the queue. 1, 2, 3, 4, 5. We can have 5. 6. So the values are 10, 5, 9, 15. So this is the front pointer, and this is the rear pointer. So when we are removing a value, we are doing Dequeue. What we are doing, we are only incrementing the front pointer. So this front pointer will be incremented and it will point to the next element, and this value is actually removed. All right. So in these data structures, the ADTs, we are not actually deleting the values. We are actually dealing with the pointers which are pointing to the values. All right. So there can be a step that you can add in your code in which the value which you will remove can be returned, and many times they are stored in a variable before the pointer is pointing to the next index, so that that value can be sent back from the function of removing, and that is up to the requirement of that question. So you have seen that the front pointer is incremented. And what is the other thing that happened here? So you should remember that as we did this, that the actions that were taken, what actions? The front pointer is decremented, number 1. Number 2, the queue length is also decreased. So you must decrease the queue length because one value is removed from the queue. All right. So this is how we do the Dequeue. This is how the Dequeue is done. And the Enqueue and the Dequeue, so they both are clear, I'm sure. Now one very important aspect of the queues, and that is what is that aspect? And that is the circular queue. The circular queue is very important. What is the concept of the circular queue? Circular queue is basically effectively utilizing the spaces available in the queue. Okay, now what is in the circular queue? Let's assume circular queue is to effectively utilize the space available in the queue. All right. How's that? Like we have a queue. Now, if in this case, let's assume certain things, that the front pointer is here. All right. And the rear pointer is here. Now, if this is the situation in the queue, what will be the queue length? Queue length right now is 5, and the queue full in this case is also 5. So when the queue length is equal to queue full, we can't enqueue. So further values are not possible to be enqueued in this case. All right. So this is the rule, that the values can only be, so we can enqueue. So enqueue is only possible if the queue length is less than queue full. All right. When the queue length is less than the queue full, only then the values can be enqueued into the queue. Okay. Now coming to the circular queue. Circular queue is a situation where the situation is that we did two dequeues, and for that dequeue, the front pointer moves here. For example, the values are actually, now this is dequeue, this is dequeue, and the front pointer is right now at the third index pointing to this third index, and the rear pointer is now on this last index, which is the upper bound. Now you can see that, in other words, we can say this is the situation where the queue length, I will write QL, right now is 3 and the queue full is 5. So we can say that the queue length is less than queue full. Now the queue length is less than queue full. So this means there is a space available. All right, that we can see here. Humanly, we can see that these spaces are available. So these are the spaces available. So, but the algorithm will find this out by this condition. If this condition is met, that the queue length is less than the queue full, number one, this is one condition, and the second condition is that the rear pointer is equal to the upper bound. So the rear pointer is equal to the upper bound. It means the rear pointer reached to the last index, which is 5. This is the rear pointer. But the queue length is still less than the queue full. So it means this is the queue length and this is less than the queue full, mean there is a space here. So what will happen in this particular condition, that if the queue length is less than the queue full and the rear pointer reach to the upper bound, then this rear pointer will move to the first index, means we will move first from here. What we'll do, we'll move it from here. So move it here. All right. So the rear pointer point to the first index. This is called the circular queue. All right. So let's do this one more. So what I said if there are spaces, means the front pointer is pointing to the any element in the queue, and the length of the queue is less than the queue full, and the rear pointer is pointing to the last index, that what we can do, the rear pointer key can be reset to 1 and the new value can be enqueued here, and this is how the space is effectively utilized in the queue. All right, this is called circular queue. All right, this is the circular queue. And the circular queue can also be done, so this can also be done with the front pointer. How? So this can be done with the front pointer as well. Means the values are further removed. So we are removing 19, we are removing 20, 21, and the front pointer reaches here now. The front pointer reaches here. All right. So when this is the case, mean the value is removed from here, the value is removed from here, and now the rear pointer is also moving. So the rear pointer is moving next. Next means more values are added, like 33 and 45. So the rear pointer is pointing to the third index. And now one more value is removed. If one more value is removed, the front pointer will also move from here to the first index. Okay. So this is important. This means that the front pointer and the rear pointer can be reset to first index if they both reach to the last index or upper bound and the queue length is still less than the queue full. So this is the condition that you should consider in order to reset or restart the queues. All right. So this is how the circular queue is done. I'm sure it is clear. So I have in my today's lesson explained the queue in detail by telling that what is the queue, what are the basic variables which are used in the queues, and what is an enqueue, how enqueue is done, how dequeue is done, what impact will come on the pointers, circular queue, and all the things related to the circular queue. So hope this is very well clear. All right.